If we combine the equation for electrical power with the equation that defines resistance, we can get two more equations for power. The first one, P equals I squared R, means we can calculate power if we don't know the PD. The second one, P equals V squared over R, means we can calculate power if we don't know the current. You don't normally need to know exactly how to derive these, but here's a quick flavour just for completeness. We start with the equation that defines resistance, R equals V over I. And then what we do is we multiply both sides by R, which gives us V equals IR. If we look at the equation that defines power, power equals current times voltage, we can substitute in the value for V. So instead of writing V, we write IR. So we end up with P equals I times IR, and that gives us P equals I squared R. We can do something very similar to derive the second equation. Start off with our definition of resistance, multiply each side by I and divide each side by R, and that gives us I equals V over R. Then go to our definition of power, power equals current times voltage, and this time instead of I we're going to write V over R. So P equals V over R times V, and that simplifies to P equals V squared over R. The I squared R equation is typically used for conducting wires that have different currents flowing through them. These power lines may carry a current of 2000 amps each, the current being bigger at times of the day when people are using more electricity. They have a resistance of only about 0.5 ohms for each kilometre of line. We can use P equals I squared R to calculate how quickly heat is lost to the surroundings. First of all, we write down our equation and then substitute in the values. P equals 2000 squared times 0.5, which gives us an answer of 2 million watts per kilometre of line. If we divide this by 1000, we get 2000 watts per metre of line, which is about the same power as a tumble dryer. Let's use P equals V squared over R to work out the power when we put a PD of 24 volts across our resistor. Again, first we write down the equation P equals V squared over R, and then we substitute in the numbers. P equals 24 squared over 50, and if we evaluate that using a calculator, we end up with a power of 11.5 watts. The maximum power the resistor was meant to tolerate was 0.25 watts, so you can see why it caught fire.